Hello everyone, I'm an HSA Beaumont student in the 11th grade, and I'm here today to talk about my PBL Level 2. It's called Bernoulli's thrilling theory. So here's Bernoulli's principle. It's a very important principle of fluid dynamics. So let's try to break this principle down. So let's start with what these variables mean. There's barely any numbers in here and it looks really weird. So let's try to break it down to make it easier. The P here stands for pressure. This small subscript 1 stands for the first point. So the first point's pressure plus 1/2 of the density of the fluid multiplied by the first point's V, or velocity, squared, plus the density of the fluid times the gravitational acceleration, and if you're on Earth, that's always 9.81 meters per second squared, and y at position 1, and y is just a fancy variable for height, alright? So when you add all these together and put them all together, they will equal the pressure, density times velocity, and the potential energy of gravity at any other point in a fluid pipe. Basically, this principle is telling us that the higher the pressure, the lower the velocity, and the higher the velocity, the lower the pressure in a fluid. Another important thing to remember is the law of diffusion. In any fluid, fluids move from areas of higher pressure to areas of lower pressure. I've got some materials here to try to demonstrate and show how cool this theory really is. Let's start with something easy. This is just normal toilet paper. So let's start with demonstrating how Bernoulli's theorem works with toilet paper. You see here we have a common piece of tissue paper, and if I blow on top of it, one would assume it would go downwards because I'm blowing on top of it, but in actuality what happens is the piece of paper flows upwards. The reasoning is because once I increase the velocity of the air at the top of the tissue paper, the higher pressure at the bottom tries to come towards the top, pushing the tissue paper upwards. I've also got here 2 balloons. Now when I blow in between these 2 balloons, one would assume they would go far apart because I'm blowing in between them. But in actuality what happens is that the balloons come together. Pretty cool. So now let's move on to a really exciting example. This example uses a tube, some ping pong balls, and a leaf blower to really demonstrate how Bernoulli's theorem really works. So let's start by turning this on. It's a little loud, so watch your ears. So basically what happened is the higher velocity of the air at the top of the tube caused an area of lower pressure, and the higher pressure from the bottom of the tube forces the ping pongs through the tube and into the air, and that's what causes big mess. So you see, Bernoulli's principle is a really interesting theorem that talks about fluid dynamics, and without it we wouldn't have a lot of things we have today. For example, airplanes use Bernoulli's theorem to create lift with the shape of their wings. Also, without Bernoulli's theorem, our plumbing systems would be harder to manage because the pressure in the pipes would be too large to manage. So we really need to be thankful to the 18th century mathematician Bernoulli for his contributions to science and fluid dynamics. Thanks for watching and have a good day.